Hello. In this presentation, we're going to talk about our hazard communication system at Celanese while you're working for Spherion. Um, so the objective of this is for you to understand there are 4 ways that hazards are communicated at our plant. We have hazard classification types, labels and warnings, safety data sheets, and then the site hazard communication program. So hazardous communication program is defined as or also called HAZCOM, refers to how we inform our workers of chemicals used on our site that have an adverse health, physical, or environmental effect. Hazardous chemicals can be a solid, gas, or liquid. So this whole thing is referring to how we communicate the hazards of different like chemicals and products that we use on our site in our manufacturing process. Hazard classification. So first, we're going to start with a health hazard. A health hazard is a chemical that can cause acute or chronic health effects if not properly handled. Acute just means the effects occur rapidly, like rubbing your eye with an eye irritant. There's generally short-term exposure. Chronic effects occur as the result of long-term exposure. Chronic effects last a long time. An example would be cancer. So if you smoke cigarettes, you might not, cancer wouldn't be an acute effect, it would be a chronic effect. Hazard classifications. So health hazards are grouped into different classes. You can have a toxic health hazard, a sensitizer health hazard, and that's just a chemical that causes people to develop an allergic reaction. A corrosive health hazard, which is a chemical that causes visible destruction of living tissue. I think of like an acid when I think of corrosive. An irritant is a chemical which causes a reversible inflammatory effect on living tissue. And then an asphyxiant is a chemical that prevents breathing by depriving oxygen, leading to unconsciousness and death. And again, these are all classifications of health hazards specifically. You'll see these kind of pictograms when it comes to health hazards on chemicals. First of all, the skull and crossbones is toxic, meaning it has a lethal dose to it. The exclamation point is an irritant, acute toxicity, narcotic effects. Corrosive has the hand or the bar being burned by acid. And then just a general health hazard has the man with the heart symbol there on him. Now, outside of health hazards, we also have physical and environmental hazards. A physical hazard can be thought of something like anything that causes things to burn, explode, or create reactions when exposed to water or air. Environmental hazards would be any chemical that can pollute the air, water, wildlife, plants, and cause long-term or short-term impacts on the land and aquatic organisms. So here are some physical and environmental pictograms. Like I said, physical is more your explosion hazard, your flammable hazard, the oxidizer, the compressed gas, because if a compressed gas bottle is punctured, it becomes a flying projectile. That is a physical hazard. If it hits you, now it's impacted your health. But in general, because it's not something that's causing like an illness, the compressed gas is a physical hazard. And then you have your environmental hazard, which is the dead tree and dead fish that you see down there. Fire hazards are measured by its flash point and flammability range. Flash point is the lowest temperature at which a chemical will generate enough vapors to ignite. The difference between flammable and combustible is the ease with which the chemical burns. A combustible flash point is between 100 and 200 degrees Fahrenheit, and a flammable flash point is below 100 degrees Fahrenheit. An oxidizer is a chemical that promotes combustion in other materials. An oxidizer starts fires through a chemical reaction. Oxidizers can accelerate the fires. For example, hydrogen peroxide is an oxidizer. Pyrophoric is a chemical that will ignite in air at temperature of 130 degrees or below. Lithium and powdered aluminum are common pyrophorics. Compressed gases are hazardous as they are under high pressure in a container. The rupture of a pressurized container releases gas with great force, and the container can become a projectile. An explosive is an unstable chemical that causes a sudden release of pressure, gas, and heat, like gunpowder or fireworks. Reactive chemicals create gases that will burn or explode. This happens when the chemical decomposes, is under pressure, reaches a certain temperature, or is mixed with another compound like water or air. So each hazard class is divided into a hazard category. Categories assign a number that tells the reader how severe the hazard may be for the hazard class. The lower the number, the higher the level of severity. So a category 1 hazard is the highest severity type of hazard. Category 4 would be the lower type. So hazard communication labels. So chemical makers evaluate the hazards of their products. By law, they provide what's called a safety data sheet that includes hazard warnings and mitigation actions. Labels with a summary of hazards are also attached to the containers of the chemicals. The SDS provides a detailed explanation of the hazard, and labels provide a summary of the hazard. Labels purchased or shipped chemicals contain 6 topics. So your label is going to tell you the name of the chemical, the name of the manufacturer, any hazard pictograms that go along with that chemical, some sort of signal warning like danger or warning, a hazard statement like extremely flammable gas, and then a precautionary statement that tells you a summary of how to prevent incident with it, how to respond if there is an incident, and storage and disposal. Here's a sample label of what you might see on the side of a container. You can see this one is a health hazard and it is flammable. It says it's dangerous. It tells you how to store the product. It says keep the container tightly closed, store in a cool, well-ventilated area, keep away from heat, no smoking, that sort of thing. It tells you what to do in case of fire, so you can't just put this one out with water. It requires a dry chemical. And then what to do for first aid if you are exposed to it. Similarly, with this sample label, this one is toxic and it is flammable. It tells you some precautionary statements like do not eat, drink, or use tobacco while using that product. Tells you right at the top, danger, toxic if swallowed. This sort of information you're going to find just right there on the label, and it's kind of a summary of the important information you need to know about that chemical. Any chemical purchased and received must have the manufacturer's label attached. So all received chemicals should have a label attached to them. Labels must not be removed from chemical containers. If the chemical is moved to a portable container, the chemical must be used immediately and by the person who transferred it, and must stay in their possession to prevent others from using an unlabeled chemical. So the DOT, you might have seen these on semi-trucks going down the road or on train cars. They also use labels to show any kind of hazards in their transportation containers. So chemical manufacturers provide safety data sheets to communicate the hazards of chemicals shipped. SDSs were formerly known as MSDSs, Material Safety Data Sheets. They have 16 sections, and each section contains specific information. It is Celanese policy that an SDS be available for each product, process stream, and purchased chemical. Not all purchased chemicals are hazardous, but Celanese's view is the optimum approach is a full inventory of safe handling information. There are 16 sections on the SDS. Generally, the first 8 or 9 sections are what you're going to see on the label, kind of as a summary. And then the SDS has more of the technical information where it adds in sections 9 through 16 about reactivity, toxicological information, ecological information, disposal considerations, etc. Where do you find the SDS? So like I said, we keep an inventory of all these SDS sheets. They are located in Celanese's SharePoint, their product stewardship information system, where they are kept online. To see an SDS for any chemical on site, just contact your team leader or supervisor, and we can get that for you. Our hazard communication program includes the following. So we talked about the labeling and other form of warnings, those detailed safety data sheets, appropriate protective measures like signs and toolbox meetings, and then training, which is what we're doing right now. The written plan. So all workplaces where employees are potentially exposed to hazardous chemicals must have a written plan which describes how the hazard communication program is implemented. Included in the written plan is the following: a list of the hazardous chemicals present using an identity that is referenced on the safety data sheet, the methods used to inform employees of the following: the hazards of non-routine tasks, for example, cleaning of reactor vessels, and the hazards associated with chemicals contained in unlabeled pipes and stationary process equipment in their work areas. So the employer responsibilities under the hazard communication program are to create a written plan that describes the site's hazard communication program and how it will be implemented, identify and maintain a list of all hazardous chemicals used in the workplace, ensuring their SDSs are current and readily available, provide training on the site's HazCom program, ensure that labels on containers of hazardous chemicals are not defaced or removed unless the container is immediately relabeled, ensure that labels or other warnings are legible and prominently displayed or readily available in the work area, and then if employees speak other languages than those used on the label, to add the information in their language to the material presented. The employee responsibility is to be able to identify and understand the potential hazards of chemicals in your work area. You're supposed to know how to obtain the SDS, and again, you need to go to your team lead or the supervisor to get one on any chemical out there that you're going to be working with. Be able to understand and use the labeling information on containers of hazardous chemicals, so you should be able to read and understand what the label is telling you to do. Follow the necessary precautions, safe work procedures, and protective measures to use and handle hazardous chemicals. Maintain an awareness of all aspects of the HazCom program, including a general understanding of how its elements interact, and then take the HazCom program training. So in this module, you've learned that chemicals have many classes of hazards, that the hazard communication program includes the following: the hazard classification, safety data sheets and labels, and information and training. The employer and the employee each have a role in controlling exposures to hazardous chemicals, and you should now be ready to take the verification test that follows this module. Thank you.